All right, hi guys. So I wanted to go over some of the benchmark with you. I'm not going to go over the genetics, but I will start with the ecology so that you can see and how to work through some of it since we haven't exactly been there. So if you're looking at the trophic levels, the hawk is going to be your tertiary, secondary is your mouse, secondary is your snake, primary is your mouse, and then your producer is your grain. As you move up the pyramid, energy is going to increase. So you'd start at the bottom with the most energy, and as you move up, your energy is going down. Okay. So which organism provides the greatest amount of energy to the organisms shown in the pyramid above? So if I was to look which one's going to give the most energy to everything, it's going to be the grain. Why you'd want to stop at hawk thinking that that would be the case. In this case, the grain feeds the mouse feeds the snake feeds the hawk, and that would be how that works. Which organism receives the least amount of energy transferred through the trophic levels? In that case, it would be the hawk. He has the least amount. If the snake population, what will happen to the mouse population if the snake population decreases? So in this case, we're saying that the snake population is going to decrease. So we're saying that the snake population will decrease, which means the mouse population is going to increase in that case. Here we have another set of food chain, and we have our primary producers, because they are going to be the ones that are autotrophs, our primary consumers, secondary consumers, tertiary consumers, quaternary consumers. So which organism is a primary consumer? That would be your grasshopper. He is primarily consuming the grass. The frog is on which trophic level? Now, it seems like kind of a hard question, but it's really not, because all you have to do is count 1, 2, 3, 4, 5. In this case, the frog is in the third trophic level. The frog is going to be your secondary consumer. Here's your primary consumer, secondary, tertiary, quaternary. Because then the grasshopper eats the snake, the frog eats the grasshopper, the snake eats the frog, and then the bird eats the snake, and on goes the circle of life. All right. If 1,500 kilograms of biomass is available to the ecosystem by the producers, how much will be available for energy in the second trophic level? Very easy here. This is called the law of 10%. So what happens is every trophic level that you go down, you lose 10%. Now, I know that sounds like a lot, but really all you have to do is, because this starts with 1,500, all you have to do is get rid of a zero. So this would be 1,500, 150, and then you'd go down to 15, and so on and so forth. All you have to do is just get rid of a zero. How many trophic levels are there in this food chain? So if we counted 1, 2, 3, 4, 5, there are 5 in this trophic level. Which organism receives the most energy from the producers? So here's our producer in our grass. So which one's going to get the most would be our primary consumer. He's getting the most energy, most bang for his buck by consuming our primary producer. The grasshopper is, because he's not eating anything else, he's an herbivore, which means he eats herbs or grasses or anything like that, no meat whatsoever. If a forest fire destroys a forest and leaves the soil intact, what type of plants will most likely grow first within the secondary succession? Now, if you read the PowerPoint, or you can look up at the top of the next page, and you will see that here it tells you which one it is. It gives you them. If you're very careful on the benchmark, you'll actually see that the answers are in the questions. You just have to be very careful in reading it. And in this case, you get grasses and mosses and shrubs and trees and stuff like that. The PowerPoint says one thing, lichen, mosses, all that. That's going to be the answer to that question. Okay. A. What succession is this? This goes from bare ground and everything starts to kind of grow up. This is called primary succession. After something is wiped out by a tornado, by a fire, by anything like this, this is where we start to see some growth being brought in by the birds, because they drop off different types of seeds, and this is called primary succession. Even though something's burned to the ground doesn't mean it won't come back. This is primary succession. Secondary succession is where you kind of see more growth and where we'll get back to those hardwood trees. It does take time. It will take more time for it to happen, but eventually it will happen. The organism above that represent the pioneer species. The pioneer species are going to be the ones that are the very first species. And in this case, again, we have the lichen and the mosses. They're the ones that settle in first. Those lichens, those mosses, they'll be the first thing we'll see. Um, Number 5. A group of organisms, such as shown in this figure above, is represented by which level of organization in the ecological hierarchy? This is called a community. Okay. And then number 6, a group of organisms, as shown in the figure below, represents which ecological hierarchy? That's a population. So we've got a community and we got a population of fish going. All right, number 7, this seems to give several of you some issues. On 20 acres of grassland, there are 2,000 grasshoppers, 60 prairie dogs, 22 coyotes, and 10 bobcats. What's the population density of the grasshoppers? All you have to do, if you looked in the PowerPoint, it would have told you, you take the amount that you're looking at, amount of whatever animal, whatever bush, whatever, and you divide it by the amount of space you have. So in this case, we'd take 2,000, divide it by 20, and you'd get 100 grasshoppers. And then you do the same thing for the bobcats. So you take that 10 bobcats, divide it by 20 acres, and you get 0.5. So which population has the highest density? Of course, it's going to be the grasshoppers because you have more. And the lowest would be the bobcats because there is indeed less of them. All right, number 8. We actually did not get to this. So if you're looking at number 8, you'll notice that the American bison grazing in herds for protection because they clump together. That looks more like B. Eastern bluebirds claiming territories 150 yards away from each other. That's A. They're pretty much evenly dispersed throughout. Trees germinating from seeds that are blown by the wind. That's all random. That's C. Number 9. Label the following populations as logistical growth or exponential growth. A is exponential growth, and B would be logistical growth. So 10 says, which model above represents a population that appears to have unlimited resources? In that case, it's exponential growth because it can keep going and going and going forever. Which model shows birth rates exceeds death rates? That would be B, because what's happening is there's more births than there are death rates, and that's simply just a definition of logistical growth, which again we have not got to. Which are some of the limiting factors that may cause a population to reach its carrying capacity? Is water, CO2, sunlight? Any of that can be a limiting factor. 13. The birth rate is equal to the death rate in a population when growth is 0. This is represented by the dashed line in the figure. The carrying capacity is exactly where the birth and the death rate are close together, and they are side by side, and there's no difference, and that's the carrying capacity of that particular growth. All right, 8 with the pond. This one kind of gave a few of you problems. First off, because you really can't see it unless you open it up in Canvas and look at it. So a population of filamentous algae commonly grows on the surface of ponds. During favorable conditions, the population can increase quickly and cover the entire surface of the pond. How will the increase of growth of the filamentous algae growing on the pond surface most likely affect the pond's ecosystem? Now the answer here is the increase of algae is actually going to block the sunlight for the autotrophs. So because of the algae, it takes all the nitrogen cycle and all that, and it stops the growth, and it doesn't allow it. All right, so to finish up, according to that diagram above, what may be a possible explanation for the increase in algal blooms? And that's just the increase in nitrogen because animals excrete waste. So the answer to C is also